got a couple people online and some people here at Caltech that are standing by, but we're very excited to have David Lang, the co-founder of Open ROV, here today. And through DESSC and UNOLS, we often deal with sort of the larger, more technologically involved components of deep ocean exploration and science, but what David's doing is really kind of mobilizing the other side of that and getting these sort of tools into the hands of anyone who wants them. So we're excited to hear about everything he's got going on. So take it away.
Well, thank you for the introduction. And yeah, that is interesting. It really is the other side. I mean, I really don't consider myself part of the ocean exploration community, or I didn't, I should say, like a year and a half, 2 years ago when we got started. And I'll go through kind of the origins of our project, but what we increasingly are finding ourselves in that world and part of that discussion. So we're learning very quickly, and I also think we're bringing a kind of an interesting perspective. So to start off, I want to make sure I can go forward. Okay, yeah. So to start off, I just want to make sure you guys have an idea of what I'm talking about when I talk about these Open ROVs. So Open ROV, from one perspective, is an actual physical product. It's a low-cost, open-source ROV that we've been building and working on for the past 3 years. And here's a photo of the ROV. As you can see, it's got a regular kind of off-the-shelf webcam. It streams HD video. There's normally a tether attached that sends that video. 100 meters is the depth capability. It's got onboard batteries. It's got a controller board that we've developed. It runs on a BeagleBone, which is a miniature Linux computer. It runs Node.js and Arduino. And it's got some props, which are just off-the-shelf brushless motors that we found have worked quite well. And it's very simple. It's got LEDs and lasers for scaling, but it's very simple. And our goal was to make this something that was low cost enough that anyone could afford, but also something that was actually scientifically useful. So that is Open ROV. There's a photo of it underwater. That's a photo taken at Lake Tahoe. But this is kind of the origin story of the whole project. So I met my friend Eric Stackpole almost 3 years ago now, and he told me this story of this underwater cave in the Sierras, and it was the story of gold, and he wanted to build this underwater robot to go and explore, and it sounded like a lot of fun. And he also had started to develop this prototype ROV, and he had ambitions of going and exploring this cave. I thought it was pretty cool and started hanging around, and from there we decided to try and make this a little bit bigger project and broaden the scope. And so we created this site called Open ROV, and we shared our designs online and invited anyone and everyone to contribute, improve, and participate with that design. And so we initially started these forums, and for many months it was kind of only Eric and I and a few others on the forums, but then it slowly started to build up speed and momentum, and we had a few more people contributing, and the design improved enough to the point where we were actually able to go to that cave and explore. And so here are a few shots from that. And from there, the story really got out. The story got out in the New York Times, and there was a lot of people. There was a lot of people who were interested, and so all of a sudden we were inundated with people who wanted to have an ROV for whatever their uses might be. And so we put the project on Kickstarter, and were able to raise some money. So it was, we set our initial goal as $20,000, and we were able to raise that in just a few hours. And we ended up raising $100,000 on Kickstarter, which 2 years ago was actually a lot of money. I mean, now you see projects on Kickstarter that make that in a 45 minutes, but for us that was a big deal. And we all of a sudden found ourselves in this position of having to manufacture these things. So we were planning to ship these things as kits, and that's what we did. And these boxes started showing up at our garage, and all of a sudden we realized we were in a little bit over our heads. So we had to get a little bit bigger space, and we hired some people, and finally got these kits out there, and we were able to manufacture and ship these kits. And they've gone all over the world. They've been, in lakes and oceans and caves and cenotes and down in Antarctica. And there's a photo that just came back from Cuba, I believe, off the coast of Cuba, and it's a silky shark. And this is an old photo of the folks in our community, but the updated photo is fairly similar in distribution. And so that's what we've been doing. I mean, we've been working really hard to improve the design, and we've also been working hard to, instigate our community, because we've got all these really smart and interested people who are getting into underwater robotics and ocean engineering for the first time through this project. This slide is important. This kind of seems like a goofy photo, but I snapped this photo on the way down to a meeting called Oceans 2020, which was a gathering of, that NOAA helped organize, and there were people from Scripps and Woods Hole and just about everywhere participated in talking about what is going to be the future of ocean exploration. And we were invited to give a talk on our presentation, and I snapped this photo on the way down to the airport, and I included this photo in the presentation, and I said, I thought this photo was worth taking because it's two guys and it's 3 ROVs and it's all carry-on luggage. And, that was just kind of a photo I wanted to include, but it ended up being a really important slide because I didn't realize this was going to happen, but that was a big eye-opener for this group down in Long Beach, and because that is a totally different paradigm when you have 2 people, 3 ROVs, and it's all carry-on luggage, something that everybody can do and afford. That's a totally different paradigm, and I realized right then that something really important might actually be going on. And it's not just us. I mean, the story is bigger than Open ROV. The story really encapsulates this whole maker movement. So this idea of these digital fabrication tools like 3D printers and laser cutters and CNC machines that are all accessible at these maker spaces, and these low-cost Linux computers like Raspberry Pi and BeagleBone and Arduino microcontrollers and open source software that runs all that stuff. It's really enabled a bunch of people to try things in totally different ways because the cost of prototyping and producing these devices have gone down exponentially. There's people making low-cost CTD devices. I know a lot of people who are doing this. And then, the other story of this is crowdfunding. People are able to raise money to make money to actually make these projects. They don't have to go out and get a grant. They can just get a little bit of money to go a long way. And so I've started talking about this idea. There's this term called citizen science that gets floated around. And that's really a term that's been dominated by the ornithology folks, the bird people, who've really done a wonderful, wonderful job of getting amateurs involved in doing research and actually taking that data and making it useful for research. And I think that citizen science term is it's great. I think what they're doing is awesome. But what I think is happening now is something that's bigger and broader than that. Is that all of these low-cost tools, plus an internet connection, and plus these communities of collaboration that are popping up, are creating this whole new, I don't know what to call it yet, but I've been using connected exploration because that doesn't seem to me like it's science. Because science has a very, very specific definition, and science is about things being peer-reviewed and published in journals. And this is a more feral type of science than that. It's people who are curious and have a question and or just want to go and figure something out. So I've been using the term exploration. But the important part, I think, is the connectedness. is that the rate at which people are sharing and improving what they're doing is pretty impressive. This is a photo of a friend of mine, Chris Anderson. The photo was probably taken 5 or 6 years ago. He was in his backyard playing with his kids up with a remote aircraft, and also had some Lego Mindstorms, and realized that he could make a low-cost autopilot for these RC planes that they were flying. And so he started this website called DIY Drones, and just started building open source, low-cost autopilots with this community online. And that has evolved into this group of 60,000 people making all sorts of quadcopters. It kicked off this huge boom in drones, and now you see these everywhere. I mean, this is something that almost everyone takes as common knowledge now, is that these drones are low cost and very capable of taking video. But that wasn't always so obvious. And now people are using these for wildlife poaching. We had a group here who's a volunteer group. They work with NOAA, and they're the group that gets the calls to go and help out when whales get caught in crab traps. So they are going to start using drones to help them identify where these whales are, because they have a tricky time trying to figure out where they are. Another guy, Shelby, is a National Geographic Emerging Explorer, is working with drone technology to monitor coastlines and marine protected areas, and trying to combat illegal fishing. So there's all sorts of applications for this technology, and the most interesting aspect is it doesn't take a huge grant to buy one of these things anymore. It's something that is a consumer off-the-shelf product. This is another photo I like to share. This group is, first of all, this group is taken in the exact same garage that I showed earlier that all those boxes came in. So this is a garage in Cupertino, and this group there is a group of guys who thought, hey, all these parts, all these components that are going into cell phones, what if we turn those into satellites and try to take images of the Earth? And they created this company called Planet Labs, and they've since launched about 70 of these micro satellites. They call them doves. And there's 71 of them, and there's going to be more even by the end of the year. Or maybe it's the Antares explosion may have thrown them off a little bit. But they are going to have an image of the Earth, every location on Earth, updated every day. And if you go to TED.com right now, you can see that this is Will's TED Talk. Will, the CEO, his TED Talk is on the homepage of TED right now, talking about what they're doing. It's amazing. I mean, it's amazing that this kind of stuff is possible, and it all has to do with this low-cost prototyping equipment. They have a new model of their satellite that comes out every 6 weeks, basically. They're updating that fast. They're moving that quickly. All these low-cost MEMS sensors, things like that, all the sensors that go into your phone are really driving this. And the impressive thing to me is these guys came out of the same garage that we did. These were Eric's roommates. This is something that's not distant. This is something that can happen in very small spaces. You don't need to set up a research institution to make this kind of technology happen. This is an image they kind of identified a forest fire just as it was getting started, and I still don't think we know what we're going to do with having images of the Earth every single day, the entire Earth. It's pretty exciting to think about what's possible with that, and it's also exciting to think that we don't even know how we're going to use it yet, because I think there's going to be a lot of really cool applications, especially for science and conservation. So that's something to keep an eye on. The group is called Planet Labs. And so this kind of gets back to my theory of what's happening, is that we have this very narrow view of citizen science, is that these amateurs are out snapping photos of birds and participating in Christmas bird counts, or they're sidewalk astronomers. And then there's traditional science that happens within universities in papers. But these tools, what's happening right now is this maker movement, and this access to information and access to tools is really increasing this this idea of connected exploration. So anyone with an idea, anyone with a question can go out and find an answer. And so I think what's happening is something much bigger than just citizen science. And I think it's worth talking about it and addressing it and seeing how that force can be leveraged for good and for not only discovery, but also for monitoring and conservation and stewardship. And, you know, this is a photo from a group of us in the Sea of Cortez this year. We wanted to put our ideas to the test. Like, okay, how good are these tools getting? What can we actually do? And so we set out with this kind of vague goal of trying to recreate some of the work that Venture did in the Sea of Cortez by taking samples and doing some sequencing. A lot of things, we learned a lot in that process. The main thing we learned, you know, in addition to where our tools were also that this is very illegal, actually. Like it's you can't just go out there without any affiliation to a research institution and take water samples because there's biopiracy and all sorts of rules. So we didn't want to get arrested. So instead, we kind of treated this as an opportunity just to test tools. And we documented it all on this other website we built called Open Explorer. And, you know, we learned a lot. We learned a lot about what this amateur exploration or connected exploration movement is at and where it's going. And the truth is, it's very, very different. It's a different way of thinking about science and funding science and making science happen, because, you know, the NSF kind of, at least in marine biology and oceanography, I've heard these kind of terms. I've heard scientists say to me, well, the NSF didn't want to fund that because they thought it was a fishing trip, is almost like this term that they've used. And it's interesting because the way I'm looking at this whole situation is, wow, we've got a whole bunch of fishing trips going on. What if we can give them really low-cost tools and actually get them to participate in the process of discovery? And so it's really a different way of thinking about it. And like I said in the beginning of this, I don't have a lot of experience. I'm not a scientist. I'm not really even an engineer. I'm just someone who's gotten kind of caught up in something interesting that's happening. And I'm doing my best to try and to communicate what I think is emerging. And so meanwhile, there's people like us, there's amateurs like us who are, you know, kind of concocting their own kind of research studies and trips. And these amateurs we're getting a lot smarter really fast. I mean, so I'm going to go back to this photo for one moment, because this guy in the back, standing in the back with his arms up, is Josh Perfetto. And Josh was the guy who created Open PCR, which is a low-cost $600 PCR machine. On Kickstarter, I wish I had a photo of this. He just came out with an Open qPCR, which is going to be a $1,500, $2,000 device that's going to be a very functional qPCR machine. And I think that has a lot of implications for not only kind of amateur biologists and DIY biology, but also for labs in the developing world, and just it has a whole lot of implications. And so the tool has gotten better even since we went into this trip in January. It brings me to this group, which is I think they're in Germany, it might be in the Netherlands, but they organized this idea called Ocean Sampling Day, which I thought was a cool idea when I read about it. And what they did is they got a bunch of researchers. They tried to coordinate researchers doing a similar idea to what we had in the Sea of Cortez, but they got research groups to do a sample every single day, or not every single day, on one specific day. So the idea was that Ocean Sampling Day would become this Christmas bird count of marine microbiology. And here's the group that did it, and they made this fantastic app. And they also had this Ocean Sampling Day Handbook. And I read through this thing, and this was after our trip to the Sea of Cortez, and it had almost all the information I would have needed. Like, I spent a lot of time, you know, talking to the State Department, you know, talking to researchers, trying to figure out what we needed to do, how we would do this. They had all of this in a handbook. And they also had ways like legal waivers that you can get from governments and regulators to do this, and they also had testing sequencing centers set up where you could take your sample and send it in and get it analyzed and contribute to this broader database. So they had done so much of the legwork. So to me, what's happening is it's kind of a collision course, is that there's all these interested and curious and increasingly technically enabled amateurs, and then there's also these scientists who need to figure out a way to do more with less. This is another example of the places I see this intersection happening. So this is Ocean Networks Canada, and it's a really cool project. What they're trying to do. I clicked on their citizen science tab on their site, and I thought it was really funny because it says, we're looking for a few 100,000 volunteers to help analyze deep sea videos, which to me there's an incredible amount of hubris to that sentence, to ask 100,000 people to participate in your project. I mean, it's bold. I hope they're able to do it. And then on the other end of the spectrum, there is this Facebook group that I'm a part of that's got 3,000 members that is called Marine Creature Identification. And it was started by that woman, Katie, right there. And she is a diver who lives on this island in the South Pacific, and just started sharing her photos online and asking people to help her identify what she was seeing. And can you hear me?
Yeah, still good.
Okay. So she started cataloging what she was doing and asking for help. And now this group has 3,000 members, but 3,000 very, very passionate members. If you post a photo in there of a marine creature, it will be identified and there will be discussion about what it is. And it's a very, very productive group. So how do you marry that kind of need of the ocean, or the Canada Ocean Network, and this passionate group of people who have kind of assembled on their own? And then so this is actually a very old photo. We had just launched Open Explorer when I made this presentation, but we now have hundreds of these expeditions of these amateurs on Open Explorer who are. You should actually go to Open Explorer and check it out because it's quite fantastic to see what people are doing. And there's even professional scientists on there who are now raising funds for what they're doing. But it's this idea that we need to figure out a way to marry, or to make that intersection of amateurs and professional scientists as productive as possible, because there's so much potential there. And so this is our attempt to try and figure that out, to see what can happen. There's people looking at these amazing sunken these flooded caves in northern Wales, and wrecks in the Adriatic, and there's people planting native habitat for butterflies in San Francisco, and then people wanting to look in the Salton Sea. There's all sorts of really, really interesting things happening, and I think it's something that can change, that can scale, something that can scale, and also something that can surprise us. And so that's what we're doing. We started off building just hardware, and now we're really focusing on emboldening these citizen explorers and scientists, and creating better tools for them to collaborate and work together, and to continue whatever it is that's happening, and just see exactly where it leads. And that's it.
Sweet. Well, thank you so much. Yeah, that's great. Is
that too long? Too short?
That's perfect. Just to sort of start off with some questions, can you sort of discuss what the specs are of the ROV, and maybe some of your favorite functionalities that other people have programmed or added on to the base?
Yeah. So can you still see my website, my page?
Yeah, your desktop, we can still see that.
Okay, so I'm trying to get through to the community. Okay, so the specs of the ROV are, it can go to 100 meters of depth, and it's, goes about 2 knots. It's, I don't know what else you're kind of looking for. So it's 1080 video, all that stuff. The forums are bustling with people who are trying all sorts of different things. So these guys are doing structure from motion, photogrammetry. There's this guy's making an acoustic location system, trying to make a low-cost acoustic positioning system, and he's got people contributing from all over the world. So there's all these side projects that are emerging around the system. So let me see what else. There's a few people who've tried to make grabber arms. That's something that I think will happen. Maybe I can give you a quick. Is that kind of what other specs were you hoping for?
So I mean, is there like a power limitation?
Yeah. So the batteries on board can go for about between 2 and 3 hours.
Okay. Yeah.
Well, you just switch them out, and then you can keep going.
Sure.
And as far as autonomy, I mean, we have depth hold and heading hold, and we're starting to do a lot more with that because it's got an onboard IMU and depth sensor and pressure and temperature. We're very close to a lot of people are working on conductivity, so this thing will be basically a swimming CTD device for hopefully less than $1,000. And yeah, so we're moving along. So Open Explorer, our internet's bad here today actually, but you know, I can show you a few of these projects that are happening now. You can see there's quite a few more. So this is a group that just got back from Papua New Guinea, and they set up this kind of oceanographic research center there in Papua New Guinea, and they built 6 ROVs in Papua New Guinea, and Papua New Guinea has never had an ROV. You know, they've never had this kind of stuff before, and now there's going to be all this deep sea mining that happens there, and this is really an interesting idea, is to set up kind of remote observation with people who live there. Let me see what else is. There's another cool one that just came up the other day. This is a researcher in, she's at UC Santa Cruz, but she studies a resident population of blue whales in Sri Lanka, and is trying to, you know, take an ROV and do live streaming, but also she's trying to raise money here on Open Explorer. So one of the things you can do is you can actually contribute to the projects that are happening. So it's almost like Kickstarter for science and curiosity. And so she's raised $1,000 in the past couple of days to fund her research. And then I really would just encourage you, if you're curious about what this is about, you know, actually going to Open Explorer and checking it out, because there's some really, really exciting stuff that's going on with these different groups. This is researchers in the Channel Islands. Yeah, I could keep going on and on.
That's awesome. Yeah, so there was a question about taking new applications, I guess in terms of like hardware to go. Oh, okay, yeah. Like new expeditions to be uploaded onto Open Explorer, and like starting your own sort of project that way. How does that all work?
You just start it. You just go here. You just go to begin right here at the top, and you just say what you're doing, and you can accept dollars, you can accept bitcoins, you can, and then you just start posting. It's very easy to get started. I mean, this guy just did his the other day. He's taking an Open ROV to study superglacial lakes in Nepal. And you know, you just create this background post, and then it's on the map, and then you're good. And
so I know with Kickstarter, there's sort of some debate over like the accountability and vetting of some of these projects. Are you concerned about any of that, or do you do any sort of quality control?
Well, the interesting thing is that I tell these people not to. I do quality control, but so I approve. We approve all of the expeditions that go live on. That it's you're asking a question, and Kickstarter, you know, has those rewards where people are pledging hundreds of thousands of dollars to get some physical thing. Ours, I don't encourage that, so it's not front loaded. So this contribution can go forever, so you can keep contributing. The way our system is designed is to promote sharing. And so the people who get the most contributions so far have been the ones who have been the best sharers, the ones who create videos and share what they're exploring. And so the goal is that people spend the time to actually communicate what they're doing. We also have foundations who stepped up. And so for like this woman this is actually the original citizen scientist who discovered sea star wasting syndrome. She's a diver, but she was also, she was the one who figured it out and brought it to the attention of scientists. And so what we have is the Gordon Betty Moore Foundation have given us a grant to send out ROVs to interesting projects. And so she was one of them that we got an ROV out to. And that, kind of sparked a lot of the work she was doing with sea stars. And so this is a good example of, not just, she's modified it a little bit. This is a good example of not just like Kickstarter where there's, people funding it, but also a way for foundations and companies to actually support this process too. So it's pretty exciting. I mean, we're still working out. We're learning. A lot of this is new for a lot of us, and we're trying to figure out as we go. This is kind of a cool story. This is a group in New York. It's an oyster farm. So this family has an oyster farm, but they're actually very curious about sampling and monitoring nitrogen levels, algae types, trying to figure out what oyster farms actually are doing to the environment. And so they've made this a big community project where they've got an Open ROV now, and they've got the whole community involved with building and studying this area. So it's just getting started. We've only been doing this for 2 months. There's already 125 expeditions, and there's been over $100,000 worth of contributions and sponsorship dollars that have gone into it in just a few months. So I'm optimistic. I think that this could be a really, really great tool for not only kind of citizen scientists and amateurs, but I think that this could be a good tool for scientists as well. So I'm interested to see where it goes.
Trying to find. We had a question coming in that I'm trying to locate. Here we go. So what do you think is the sort of the lower depth limit? Like right now it's 100 meters, but what's to stop it from getting deeper, and how much harder is it to engineer that?
It's not that much harder, actually. I mean, it's you need new end caps, a thicker electronics tube. I mean, to be honest with you, a group of the R&D team just got back from Lake Tahoe yesterday, and they had one of our ROVs down at 260 meters. So I'm not going to advertise that yet, but that's something that just happened. I mean, it's not, you can modify these things. I'm just on this expedition right now, and Darcy, you can see this, you can watch these videos, but he was at, I think he was at, yeah, he's at like 110 meters.
Okay. Wow.
And so
what about sort of like the power and weight limits? Like, would it ever be feasible to collect samples, for example?
Yeah, definitely. I think it's just a matter of scaling. Like, this is an infinitely scalable system. You just got to add more battery power, add a little bit stronger thrusters, and you'll be able to do that for sure.
Yeah,
we're more interested in actually in like the smaller samples, like just like maybe having taking images. Excuse me, sorry, I clicked on the wrong thing. But taking the samples for just really small samples that you can then assess when you get back. So we'll see. We've got a few different ideas.
Yeah, it seems like most people are sort of modifying the software. Do you see much in terms of like the larger thrusters and more battery power, like you mentioned?
Yep. There are definitely groups who are doing that for sure.
Cool. then I was also curious about your role on the Ocean Exploration Advisory Board, and sort of what that's all about and what you sort of will be advocating for and what you see your role as on that.
Yeah, thanks. Thanks for asking about that. So, yeah, the new Ocean Exploration Advisory Board, we're actually meeting for the first time in 2 weeks, the first week in December. And, you know, like I said this whole kind of time, I'm not the typical person to be a part of something like that. And I'm really not, you know, not cut from a lot of the same cloth that, you know, a lot of people are in the oceanographic community. And I think that is my responsibility is to bring that perspective to the group. So, you know, talking more about the developments that are happening in the world of citizen science and citizen exploration, and how we can, as a community, how the oceanographic community can be an example, can set an example of just how well this could go. I think for many years, people have aspired to have a citizen science system that's as effective as the Cornell Lab of Ornithology's work. And I think we could do much better, because I think the tools are going to be much more powerful, and I think the ocean is exciting. I think a lot of people are curious about it, and a lot of people want to participate, and I think there's a lot of untapped potential, and especially when you think about the ocean exploration, you know, I don't think it's any secret that it's just woefully underfunded. You know, that it's one of those things where, you know, if you look at the budgets of NASA and all these other things, it's amazing how much the Ocean Exploration Group and NOAA is able to get done with the level of resources. So I think, you know, part of, you know, building a stronger community of amateur citizen scientists and explorers is also going to do a good job of bringing awareness, and, you know, not just the potential to provide data and discovery, but also the potential to provide awareness and public outreach. I think it's, you know, it's almost beyond public outreach, where it's not just telling people what you're doing. It's actually creating this system where the medium is the message, and you've got advocates in these different places. So I'm excited. I think that the tools have changed so dramatically in such a short period of time that there aren't any best practices yet, and this is going to be a good opportunity to try some things out and to figure out what those might be. Yeah,
that's cool. I didn't realize it was a brand new thing, so that'll be interesting to see.
You know, I think they've had these kind of advisory boards before, but this is the new one. So this is like it's a new batch of people.
Nice. I was also curious about how you sort of propose to bridge this gap of sort of citizen science and capabilities with sort of the more established like scientific process. So Open Explorer looks like one good way, but how, I mean, do you think there are good ways to advertise within the academic community or get certain people on board and show that it really works? I mean, first letting people know that this exists, but also getting the buy-in seems like a big challenge.
Yeah, I think you're right. I am not as worried about that. I mean, first of all, there's going to be people who are critical and skeptical, and I hear that all the time, and I get that, and I agree with them. But I also think it almost doesn't matter it almost doesn't matter, because what's happening, in my opinion, it's not that complicated to figure out what is happening, because you can look at what the internet did to movies and music and journalism. When you reduce the means to production. So now we've seen the internet just lowered the barrier to production for people, and like all these, you know, the iPhones and stuff have lowered the barrier to production. And like if you want to create a movie, you just click on your phone and you're automatically recording. All of a sudden, everyone has access to that. and everyone has the means of distribution, so it's very easy to upload your video to YouTube. And so for years, we've seen what that effect has had on the music industry and movie industry, and it's never like YouTube didn't destroy Hollywood. I mean, Hollywood blockbusters still exist. Hollywood goes on. All of a sudden, there's just more. There's just more options for getting filmed content out there. And it's not that you call a cat video on YouTube, you wouldn't call that a film. And I think what we're going to see here is you're not going to call like this guy looking for World War II artifacts in Danish water here. Like, I don't know that that's not going to be a citable paper, probably. So, what we're doing is not necessarily going to be science. But it's more just curiosity, and I think that's okay. I think that having more options and more models is actually a good thing, because I think right now there's a lot of young researchers who are stuck in this kind of postdocalypse where it doesn't appear that there's ever going to be a tenure track position for them, and we need more models. We need more options for folks like that to get through, and there also needs to be a way for people in the developing world to actually contribute to science. I mean, I don't know if you've seen these maps, but the amount of research that's coming out of developing worlds it's not enough. And so I think that I'm not so worried about the science community, because I think they're doing fine. I mean, the people who have tenure track positions and are publishing papers and are getting grants, that's great. That system's working for them. So I'm less concerned about appeasing them than I am enabling curious people to not only ask questions, but then to begin to protect their environment. I apologize because a train goes by my office, and there's about to be one that goes by in about 10 seconds.
No problem.
Does that make sense, by the way?
Yeah, no, that's awesome. It's really interesting. And I think the journalism parallel is also very apt, because I think journalists tried to hide behind the idea that they were the aggregators and that you would come to them sort of for the nuance and the context. And I think science often works the same way, that some people maybe hang their hat more on the fact that they have access to certain places that other people might not, and that's going to break down, but maybe by having the contextual knowledge or some way to place it within sort of the larger scientific sphere, there's still sort of a place for that. But
yeah, that's interesting. That's interesting. Like right now, like the New York Times is like this. It's still amazing to be in the New York Times. I promise you that. We've been in the New York Times, and it's still one of the best things that can happen to you as a person, if it's a positive thing. Of course, if it's a negative thing, it's not a great thing. But there are still these places where great journalism happens, and I think there's room. There's going to be, of course, there's always going to be room for that. But it is, Twitter is a real thing, and to ignore that as something that's happening would be a mistake. And it's obvious now. No journalist would say that Twitter doesn't matter, because it clearly does matter. It's just a different thing, with these new tools, these new technologies, it just becomes kind of a new normal, and it involves dealing with these new platforms and these new tools. So I don't know. I mean, will science kind of get out of the ivory tower? I hope so. I really do, because I think right now you have a situation where these interpanel climate reports come out and it just falls on deaf ears. I mean, not enough is happening. And so I really hope that this is a way for more people to get involved in the process of discovery and in the process of understanding and conserving.
Cool. Anything? All right. I think that's all we've got. So thanks again for taking the time, and this will sort of be up online and engender further discussion, hopefully. But yeah, I really appreciate it.
No problem. And if you guys have any other questions, my email is david@openrov.com or david@openexplorer.com, and I'm happy to answer any questions. And I love feedback. I mean, I don't think I'm right here. I don't think what I'm saying is like correct. I'm just saying I'm just trying to watch what's happening and learn about it because I think it's really interesting.
Yeah, of course. And I think, I mean, we're sort of as a scientific community are certainly always interested in new tools or new ways of doing things. So there's certainly a lot of overlap there.
Awesome. Cool.
All right. Well, thanks so much. And,
Thank you.
yeah, I'll talk to you soon.
All right. See ya.
Cool. Bye.